So today I want to show how I've been teaching students to find a common denominator in order to find equivalent fractions and then solve addition and subtraction with fractions with different denominators. So let's say we had a fraction such as 1/4 plus 2/5. So an addition problem. First thing I'm teaching students is before we model the fractions, before we do anything, we want to find a common denominator. And there are two ways we can find a common denominator. One is our traditional, the way we've always been taught. We can multiply the two denominators. So 4 times 5 is 20. And that tells us our common denominator. So that's a great way a lot of the times to solve the problems. There are some instances, though, where let's say we have 3/21 plus 1/7, where multiplying the denominators would end up with this huge denominator. And you can probably see that we can use 21 as a common denominator, but students don't always see this. So sometimes when students only use multiplication to find it, they miss some easier ways to solve the problem. So another way we could solve the problem is we can look for multiples. So if I was doing 1/4 plus 2/5, I might do multiples of 4. 4, 8, 12, 16, and 20, 24. And then I might do multiples of 5, 5, 10, 15, 20. Oh, there is a common denominator. So that's another way to find a common denominator. With the 21 and 7, if students know their multiplication facts, that's probably something they can see. But that might be something to encourage your students to start doing, is see if you can take the smaller number and do multiples at least of the smaller number and see if it works. And when we get to 21, we can see that they're the same, and so we know that we can use that as a common denominator. So going back to that original problem, once we do have a common denominator, we still need to, we know that our denominator is going to be 20, but what is the numerator going to be? We're going to have to change the numerators in order to solve this problem. So that's a second step, is finding equivalent fractions. So I'm going to show how we've been working on that. The first way, I'm recommending that, especially when students are struggling, that they are going to model these model fractions, and model it using graph paper, not just freehand sketches, in order to make sure that they're being accurate and showing equal groups. So on Notability, they have the option of using graph paper. The medium graph paper usually works, but anything that has a big enough squares, has enough squares, they can use graph paper. If you have graph paper at home, that's a great way to do this process. And at least at the beginning, until it becomes comfortable, it's a little slower, but it ensures that students understand what they're doing, and it helps us to understand where they're making mistakes when they're not able to solve the problems with a model. So the first step is I'm going to start with the common denominator. So I still think it's really important that students find the common denominator first. So when they set up their model, they're setting up a model that's going to work to be able to solve the problem. So when I draw the model, I want to actually create, I want to use 20 squares, a rectangle of 20 squares. So I'm going to mark this a starting point. There's my beginning. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It looks like this is not going to be big enough. So that's a good case where let's choose a different graph paper that would fit. Doing this by hand on a piece of paper certainly will be able to solve most of the problems that we're doing, at least at the beginning where students understand it. So using this, it'll be easier to get the right number. So I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20. It's a good way to develop carefulness and also to get accurate. If you were to just draw this out, students, when they're drawing fractions, often will draw shapes that are not equal size, and they end up making mistakes when they don't understand. So I'm actually going to draw two rectangles that are both 20 squares long. Let's divide that. And now I can set up both of my fractions. So I am modeling first 1/4. So I'm going to model 1/4 with this first rectangle. And the first step is I have 20 squares. I need to divide 20 squares into 4 equal parts. Well, I know using my fact family that 20 divided by 4 is equal to 5. So that tells me that if I count 5 squares, I should be able to divide that into 4 equal groups. So I'm going to go ahead and count 1, 2, 3, 4, 5, draw a line, 1, 2, 3, 4, 5, draw a line, 1, 2, 3, 4, 5, draw a line. Students might need some help going through this and watching this process, but it's usually something they can pick up pretty quick. So now let's go ahead and fill that in. So 1/4, I'm going to shade in 1/4. This is something that most of the students are really getting. They can model this part of it, and they're having no problem. Okay, so we've got 1/4 modeled using 20 squares. Now, the next step is, let's look at what would that be as, let's go ahead and change the denominator. So, how do we know how many 20ths there are? Well, we've already divided it into 20 parts, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I already have 20ths, right? So 1/4 in 20ths would be how many of those? So we have 1, 2, 3, 4, 5. 5 20ths are shaded in, right? So that tells us that 1/4 is equal to 5 20ths. So now we can go on to 2/5 and model 2/5. So the first step again is we want to take 20 and we want to divide it into 5 equal groups. Well, we know that 20 divided by 5 is equal to 4. So we are going to have 4 squares this time. 1, 2, 3, 4, draw a line. 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 And we have 5 equal parts that are 4 squares long. And we can shade those in. So this time, how many are shaded in? Well, I have 2/5, so I'm going to shade in 1/5 and 2/5. Now, we can go ahead and count those to tell us 2/5 is equal to how many 20ths? How do we figure that out? And you might think that this is easy, but for students, a lot of this is pretty tricky. Going, and so taking this time to think through this and talk through this. Don't be impatient. It takes some time for students to wrap their heads around this. So we count the squares because there are 20 squares. I'm going to count the ones that are shaded in. 1, 2, 3, 4, 5, 6, 7, 8. So 2/5 is the same as 8 20ths. So now